Hi students, welcome back. In last class we have seen about the examples related to the nature which are related to the physics. Whatever you observe the physics example or the activity, whatever you observe in our daily life. So we need to discuss about the properties. Let me tell. What do you mean by the properties? Whenever you observe a building, or whenever you observe a tree, or whenever you observe a cylindrical vessel at home, or whenever you are sitting in a chair, or whenever sitting on a bench, so wherever you have seen that one, so let me tell, cylindrical vessel, what would be the volume? Or when you have observed the building, what would be the height or what would be the width? Or whenever you want to buy whenever you want to purchase something from a market, so how much amount you need to purchase? Then what would be how much is it? 12 kg, 10 kg or 1 kg? So what do you mean by here kg? What would be the height? Is it 1 meter, 2 meter? What would be the time? Nowadays, everybody is knowing that time is everywhere. We know that second. Time is second, and we know mass is kg. Is it? And then distance can measure in meter. But before we don't know all these things. For example, if you want to buy something from a market. In our olden days, our forefathers are preferred to measure the length with a hand span. Is it like a hand span? Or they used even a cubit. This is cubit. Or by using foot or a stride. So by using different methods they used to measure. Or even nowadays also, if you want to know the area of the fields, how do they measure? By using a chains or like ropes or strings, something they make. Then is it correct everywhere? Does it give correct measurement for everybody? So let me tell one example. You went to a market, so flower shop, and you asked to the flower seller to give 2 or 3 cubits of a flower garland. 3 cubits or 2 cubits of a garland. So what will he do? Just he will measure with his cubit or her cubit, and for each cubit you have to pay like 10 or 20 rupees depending upon the cost. So let me explain. For example, you asked to me to give 2 cubits of the flower garland. So what will happen? Then I will measure with my cubit and give to you. So for me I will get this from here to here, this much length I will give, and 2 times of this length I will give to you and you will go. After you went to home, then you may check with your cubit. Do you get it is 2 or 3 or 1? Exactly, do you get 2 cubits of me? Just think about it. Will you get? For example, if your children or a kid is measured that one, then how many cubits he may get? Or how many cubits they may get? Not 2, they may get 3. Then you should give to me 30 rupees for each 10. Is it? Or not only that, if your father measured that one, the same length whatever I have given with the 2 cubits of my hand, your father has measured that, but when your father measured that, he got only 1.5. That's what I am telling here. I think you came to know the difference. That means whatever I have measured with my cubit is not a standard value. That value will be changes from one person to the others depending upon the person measurement. So that to remove the ambiguity, the confusion. So when I say 2 cubits of my hand, from here and then 2 cubits of hand, then I have taken a thread and I said to measure 2 cubits of my hand. I measured from here, then you take and measure with your cubit. Is my thread length and your thread length will be same or different? Is it same or different? Will you get same? No, you won't get same. When do you get it same? If my hand cubit and your hand cubit length is same, then only you get. So that is what I am telling here. It's not a standard measure. Then we need to adopt a standard measurement for any such type of the measurements. Wherever you are from, wherever you measure, are you measuring from America, or are you measuring from India, or are you measuring from Europe? Am I measuring from here? So wherever you measure, the measurement, the length should be nearly same. Length should be exactly same, not nearly. So that is what here. Let me discuss about some measurements and units and measurements. Okay. What do you mean by the unit? What do you mean by the measurement? I am telling that measurement. Measurement represents what? What do you measure? Do you measure? For example, if you are measuring with this duster, is it exact? Is it correct measurement instrument or not? Let me discuss. For example, here we have taken the length of this board. Here, how many times I am getting? 1. Here, 2, 3, 4, 5, 6, 7. Around 7 times of this duster. Is it? What will be the width of this board? 7 times of this duster. Is it? Now, just to understand what I am doing, what will be the length of this board? It is 7 times to that of this length of the duster. That means I am comparing this length or this breadth, the breadth of this board, and comparing with this duster length. So what does it represent? Or I have drawn a line. Is it more or less length compared to this one? This is more than this length. But can you make it shorter? Yes, you know very well. You are playing, I think. So now this is shorter than this one. How do you know shorter or longer? That is large height. That is what depending upon you compare this length with this one and this one, so that you can understand clearly that measurement is nothing but a process of comparison of known unit. Is it? Process of comparison of unknown unit with a known unit. First of all, so let me tell what is unit. What do you mean by unit? What do you mean by the unit? What do you mean by the physical quantity? What do you mean by the physical quantity? Physical quantity represents a quantity which can be measured. Anything you take which can be measured, that is nothing but what? Physical quantity. Which can be measured. Which can be measured. What you can measure? Like area, you can measure area, or length, or velocity you can measure, speed you can measure, or density can be measured, or mass can be measured, anything which can be measured. There is nothing but the physical physical quantity which can be measured. Now, to express this physical quantity, what do we require? Let me discuss that. If I ask what is your height, how do you express? You may express that my height is 6 feet or 5 feet or 4 or 5.2 feet. That means you are comparing your height with a feet. So what we are doing always, we are mentioning, or if I ask to measure with a scale 1.65 meter or 165 centimeter. So what do you get here? Centimeter. You compare your height with a centimeter. Then your height is how many times? 165 times that of the centimeter. That is what we are using, centimeter or meter or foot, whatever it is, nothing but unit. Unit. What do you mean by unit? Unit refers to the, that is what standard measurement. You should be having standard measurement. That is what here, standard measurement of any physical quantity. Any physical quantity. Standard measurement of any physical quantity, which gives the same value everywhere. That we call as a standard measurement of any physical quantity is called unit. Now, but how do we take the unit? What are the characteristics of the unit? Characteristics of the unit. The unit should be having, you can produce easily, reproducible. So it should be easy for measuring. It should be reproducible. Like unit means what you can take? Meter or kg or second. These are the nothing but what? Units of. Meter is what? For measuring distance, length. Kg is the unit for what? For measuring mass. Second is the unit for time. So the characteristics of the unit must be, it should be a reproducible. We have to produce it is easily, without, and you should not vary from one place to the another place. Invariant, unit should be invariant, and even it should be consistent, correctness, consistency. Where you measure should have consistency. And whatever we have chosen that unit, and should have the easily available for everybody. Is it? So what is the characteristics of the RICE? What is it then? Rise. What do you mean by rise? Reproducible, invariant or invariable, consistency and easily earned. That means we should not get any confusion when you are measuring. No ambiguity at all to measure. Is it okay? We are measuring the physical quantity with a by representing unit. Then how do you represent any physical quantity? When I ask what is your height, then what you tell? My height is 165 centimeter or 1.65 meter or 16.5 millimeter, like that, any number of times. 1650 millimeter. Is it? That means when you measure any physical quantity, where that unit is accompanied with a numerical value. Is it? I ask your height. you take just your height. What is your height? H is equal. I ask the height of a person. H is equal. You measure by using one instrument. So what I ask you, you express it is in terms of 1.65 meter. And I ask you one more person that, but he expressed the same in terms of 165 centimeter. But somebody said that here 1650 millimeter. Now you can observe what is this 1.65 or 165 or 1650. What are these? Are nothing but values, numerical value. And what are these? Meter, centimeter or millimeter? These are nothing but what? Unit. Okay. H represents what? Height of the object. That means height is nothing but the length of the person. Now you tell one thing. What is this value? 1.65. What is this value? 165. And what is this value? 1650. Is this value increased or decreased? Increased. That means what? The numerical value has changed. Numerical value changed means, so you said 1.65 means this length, 165 means is this length become like this? Like this? Then 1650 means is the length becomes like this? Not? Is it? The magnitude of the physical quantity P, that is remains constant. Is it or not? Your height is remaining same. Even I express in 1.65 centimeter, 1.65 meter, or 165 centimeter, or 1650 millimeter. That means even the numerical value has changed, your magnitude of the physical quantities remains same. That means you can understand one thing, the magnitude of the physical quantities remains constant and numerical value changes, that represents unit will be changed. Is it or not? So what you can write here, the relation between numerical value and unit. Numerical value is equal to numerical value is equal to numerical value into unit. Unit U is equal to numerical value into unit is equal to what you can write here? Magnitude of the physical quantity. Magnitude of the physical quantity P. From this, even we can mention even numerical value will changed. The total magnitude remains constant. Magnitude of the person or magnitude of the physical quantities remains constant. Even numerical value and unit change. Now I need to know, if the numerical value increases, what happens to the unit? Or if the numerical value decreases, what happens to the unit? Let us see. Magnitude of the physical quantities remains constant only. So what you can write here? N1, N2 U is equal to constant. Numerical value into unit remains constant. So that here we can write here unit. U represents unit is inversely proportional to the numerical value. Numerical value. Unit is inversely proportional to the numerical value n. Now, from this, based on this one, can you tell? Here I have used meter, here I have used centimeter, I have used millimeter. Now tell me which unit is having more value and which unit is having less value. What do you know? More is a numerical value, less is a unit. Less is a numerical value, more is a unit. Now can you tell? Here numerical 165 is more, then millimeter is what? Very less. Millimeter is less than. Next, meter is 1.65. This numerical compared to all these values, 1.65 value is less, so that this unit is more. That's what millimeter is less than centimeter, which is less than that meter. I hope you understood that what do you mean by the measurement, how do you measurement, what does it involve, and what do we require to measure any objects or any things. We require the comparison of unknown physical quantity with a known physical quantity. Is it? We have to find the unknown measurement, unknown object measurement with a known object. Is it okay? But here one more thing we need to know that the numerical value and unit remains constant. Before that, here we represented physical quantity. What do you mean by the physical quantity? Any quantity which can be measured is called physical quantity. Then, how do we measure the unit? What systems are there to measure the units? Let me take here. In olden days, previously, we have three systems of units, which is CHS, FPS and MPS. But here what do we have? Physical quantity. What type of physical quantities are there? What type of physical quantities are there? Is it derived or finite? Is it? So let me tell first. We know length and mass and time. These are what we call fundamentals. Length, mass, time. So this is what before 1960 only three physical quantities known. What are those? Length, mass, time. Only three. That is, and moreover, if you want, you can measure only. If you want to measure any physical quantity, just first we need to require this one. If I ask to measure what is the area of this room, area of this room means so area of this blackboard. If I ask, what do you require? It is length, it is breadth. So length, okay. And if I ask what is speed, what is the distance traveled, and for traveling that distance, what is the time taken? That is nothing but speed. Then speed is not. What do you require for measuring speed? You need length and time. But do you get the mass from anything? Mass is what? Base. If you want to write 20,000 or 2029, what do you require? You need to know the numbers 0 to 9. So, you write any number. To write any numbers, what do you require? First of all, you need to know from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So, you can frame any number by using these one. So that what? These are basic numbers. Similarly, if I ask to write your name, what do you want to write your name? You need to know the letters A to Z. A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. From these only can you take or any other values, other letters we have to write your name? Is it? That's what. What are these things? Basic. These are the fundamentals to write words or sentences. Is it? Or these are the fundamentals to write any sentences. If you want to write A and T, do you write from it? You need to know A to Z letters. So then what we call A to Z, these are the basics, and 0 to 9, these are the basics. Similar as in physics also we have basic quantities, fundamental quantities. What those fundamental quantities means? Length, mass and time. Is it okay? And again, this length, mass, time also, different unit systems are there, like CGS system. I hope you know in lower classes. In CGS system, what is the unit of the length and what is the unit of the mass and time? In length, centimeter, and mass, gram. C, centimeter. G, gram. G, gram. Whereas time, second, gram, centimeter, second. Similarly, FPS and CGS system is also called Gaussian system. Gaussian system and FPS and MKS. Is it here? FPS represents foot, P represents pound, and S represents second. Foot, pound, and second. Whereas in MKS, length, how do you measure the distance? Meter. Metric system, and this is also called metric system. Meter. And what is the unit of the mass? K represents kilogram. Kilogram. Whereas S represents second. So these are what here known systems of unit, and these are what fundamental quantities. Is it? And then we learn in next class what are the fundamental physical quantities. How do you get these fundamental physical quantities? And what do you by using fundamental physical quantities, what we can get? What is the importance of the fundamental physical quantities? And here I raise some systems of units, CGS, FPS and MKS. Then do we have any other systems of units than this one? And other than these fundamental units, is there any other units are there? And all these things we'll discuss in next class. Thank you. Keep watching.